Hi, this is FaisalIrfan. I'm a data science spring 2021. I'm grading this assignment, this video for Assignment 1 Artificial Intelligence. I'm speaking so fast because I want to give the video under 5 minutes and I'm creating this like 8 or 10 times. I'll get started. This does not have a very pretty interface. It just lets you select one of these options. I select breakfast. It works for all easy, medium, and hard, but hard takes up to 2 minutes, so I'll select easy. It turns out it prints the output as mentioned in the document in the slides. uh, I'll go for best first, so I can show medium. You see it worked for medium as well. Let's go for best first and work for hard. That's fine. And the cost is, as you can see, the cost is the same number as that of the tile number. Like the number with, if 0 is being swapped by 4, then the cost is going to be 4, and it will be added to the total cost as in the requirement document. So I'm going to go and get started with the explanation of the code. So for the puzzle, I will start with this. I created actually I will start with node. I have node object as required in the document, and it contains the state of the node and all the rest of the information, except I added one more item, which is string node. I used it for comparison, so I don't have to go through the two-dimensional loop and comparing each item one by one. So what I do is that I can take for the board state, I take a string, convert it to string like this, of course with no spaces, and then the search is quite fast. Imagine that I have to search it in the history. Maybe I have like 6,000 items in my in the queue, uh, so or in the history. I can just search it with one line, which is quite fast as compared to going through the loop and all that stuff. Of course, I had to implement hash code and equals for the to get that specific part done. So I have hash code only being calculated for string node and all that stuff. I'm not going to go to the details of this one. Um, yeah, best for yeah. So the puzzle state is actually the state of the board at any given point of time, and it allows you to find the possible moves and compare the goal state, and returns you the result set based upon the action that you're going to provide. It could be up, down, and you can see left, right, all that stuff. And these are pretty much standard getters. I'm going to go with the constants is actually the states, all the states. I wanted them these are single dimensional. I wanted them to be very close to the what input was being provided. It can run for any kind of input. Yeah, and goal state, I wanted it to be more close to the 8 puzzle board style, which is two-dimensional, in an empty set being used when I initialized all those different states. And utils is actually the class which is printing. This function is printing all that, being shared by all of them, generates the blank location, converts the initial single dimensional array to two-dimensional array, and then used by the all of these functions. I'll go with the BFS breakfast. So yeah, it uses the puzzle state function, puzzle state object, and then yeah, okay, since it implements the queue, so I have a queue in over here. And these are side getters, so I'm going to go through, not going to go through it. I'm going to go through the search function, which is the real function. So I'm initializing the queue, initializing the state history. You see I'm using a string for that, and then I store the node along with it, and base search problem, which is being used by all of those classes, and I add first a root to the queue. And once the root is added to queue, the queue is going to keep running until it's like until the queue is empty. So I take the first item out, which is the root item. I take the path of it, which is empty for now. The state history is empty for root, so it's going to keep I mean, that stack is over there. If some node already, some state or node already exists, then I just skip that one and don't process. And you can see that I'm using a string node over here. If I would have just compared it using two-dimensional arrays, it would have been super slow. And I actually did that initially, and it like sort of crashed my system. So then yeah, this one is to check if we have already reached the goal state. If yes, then we just break the loop and print everything, the complete path like this one. And yeah, then if not, then we get the successor function, get all possible of states or successors. Then yeah, if I check that if all of those, any of those children exist in the history, then I don't add them to the queue. But before the adding them to the queue, I also check if they exist in the queue or not. If they exist in the queue, I just ignore them, and then finally I add that current node into the state history.